I've modernized an intranet app using spec-driven development, and I'm here now to present the result. I took a legacy app and studied it to determine its specification, domain entities, user interface component descriptions, and user stories. I wrote this all down in Markdown files and then added instructions for GitHub Copilot and Claude Sonnet to generate code and tests. I invested a lot in test generation because the legacy app had none, which is just painful. Think of all the repetitive manual testing I had to do. I want guardrails for future development because I have no guarantee that bots can add new features without regression. We all break existing things when we add new features, so having a solid set of tests is crucial for sustainable software development. The reason that managers embrace this endeavor is that the legacy app had many known vulnerabilities, security vulnerabilities, and the new app it promises to have none, and that turned out to be true. In other words, I get a clean app. What is a spec-driven development? Well, you have to recognize that you need to write two parts of requirements: product requirements, domain entities, user interface components, and user stories, but also process requirements. So implementation requirements and test requirements. These are all in Markdown, easy to read, both for humans and for bots. The file structure that I used is next to my code project and the test project. I have simply a folder which contains all the specs and, as I said, split into process and product. I also have lots and lots of logs so that I can monitor what the bots are doing. I use progressive disclosure and don't repeat yourself to minimize what the bots need to read before they act. I also have a lot of intermediate artifacts, and I'll refer to that later, and I invest a lot in testing. Here is an example of where these intermediate artifacts worked well. When I ask a bot to generate a list of things, I prefer to make it first output a table that lists all the things it needs to do before it actually does them. This makes it more likely that it doesn't lose track of what it was doing. Such intermediate results also enable me to verify all is done and point the bot to tasks it skipped. Here's an example. I write a user stories with acceptance criteria, or I at least review the acceptance criteria before I ask the bot to implement a user story. One step in the user story implementation instructions is to add the acceptance criteria of the user story to a global list of all acceptance criteria for the application in a table that it also has columns for the test of the acceptance criteria, what file the test is in, what the name of the test is, and whether it has been implemented. Claude Sonnet sometimes marks things as done while they are not. Yes, that's true. To mitigate this, I ask it to check whether all the tests that it said it needed to generate actually got generated. This screenshot shows that it somehow managed to forget about 42 tests. Because of the intermediate artifact, the table of acceptance criteria tests, it could generate a new table or to-do list of these 42 tests and then generated them still. I deliberately chose to use as little as possible in my environment because this whole field of software development using AI or spec-driven development is so young that what is available today may not be around or maintained tomorrow. Here's an example of a domain entity. Here's an example of a user interface description. Here is an example of a user story. As you can see, I use references for further information. Here's an example of an acceptance criterion. Here it shows how this ends up in a global table of all acceptance criteria. Here's the corresponding test for this acceptance criterion. In this case, the program name is required, so deselecting it as I do there and then submitting the form should show a validation error message. Please enter a program name, and it checks that that message appears, and the test also verifies that the service is not called in this case because, well, there's a validation error. This is an example of other instructions I provide that are not user story specific. This is another example of the same kind. The longest file of instructions is the story implementation requirements file. It has many steps. It took a long time to compile this. This is the end result. I got the application modernized with a test set that covers 81% of the lines. That took over 2,000 tests, none of which was written by me. They were all generated. It was done with a minimal environment, and my job was to mostly reverse engineer the specs of the original legacy app.